So we're going to start with a case 10. Dr. Hu asked us to present it as a case. So general endotracheal anesthesia, uneventful pre-oxygenation, intubation, induction. We're going to do this to begin with that with a bellows ventilator. Oh, and by the way, I encourage audience participation. Whoever has the most participation will get a prize, and the prize is a $100 worth membership for a year to the academic area of the VAM website. The surgeon had the incision 10 minutes ago, and the analyzer alarm sounds. And I'm going to set up the simulation for you. So since you guys have used the VAM, I don't have to explain what I'm doing. I'm turning up the nitrous. I'm going to hide the gases, and I'm going to turn on my ventilator, and I'm going to initiate the fault. All right? What year are you guys in?
We're doing yours.
Okay.
Our oxygen's low.
I'm sorry?
Our oxygen's
Give me
low.
nitrous without oxygen.
Okay. So what do we have? That's what we describe in the introduction. The oxygen analyzer starts alarming. What's the first thing we do?
Check our pipeline.
Turn off the alarm so we can think. Right? Right? Isn't that what you do? Okay. Now, let's think. What do we do?
CFR.
Huh?
CFR O2's on. Check our pipeline.
Check your pipeline. I check my pipeline. The pressure is 50 psi. Here's a picture of the orange columns.
Turn our flows up.
Turn our flows up. Flow of nitrous too, or just oxygen?
Just oxygen.
Okay. I'm sorry?
There's nothing.
FiO2 keeps dropping, right? You asked me to turn up the oxygen. You want me to turn down the nitrous just to be on the safe side?
Yes.
Okay. Turn down the nitrous. So what should this be reading here now, according to the setting on the flow meter? Yeah.
O2 sensor intact. Looks like it.
The O2 sensor, I inspected, and if you want, I can even take it out and hang it in the breeze, right? And it reads 21% when I do that. Then I put it back in here, it reads 2% again.
Make sure.
So now I have a second alarm. What is that second alarm?
Take out the patient.
What is that alarm? The pulse oximeter is giving an alarm, right? So what does that tell you about the oxygen analyzer sensor? Are you now feeling more confident?
Yes.
Yeah? So that's confirming. But the other thing to remember, this is important. So the oxygen analyzer alarm came much earlier. So it's an early warning, whereas the pulse oximeter came much later. So that's why you want to have a functioning oxygen analyzer on your machine. Because the other way to look at it too is when the pulse oximeter alarm sounded, you have used your patient's hemoglobin as the sensor, haven't you? And if I was your patient, I wouldn't want that. Right? So that's why you want to have a functioning oxygen analyzer, because that was your first inkling that something went wrong. So what should we do?
I would turn off the pipeline and turn on the cylinder.
Yeah.
Okay.
And move back.
That's the right answer, because remember the troubleshooting. So you call for help, and you take an embu bag, not the bag on the machine, an embu bag,
Right.
and you ventilate the patient. Okay. And when you do that, the saturation gets better. What does that tell you? That it was the machine. All right. Now, for the purposes of learning about the machine, clearly you want to take the patient off the machine, embu bag, call for help. But for the purposes of this exercise, we want to keep on with this to the bitter end. So how are we going to troubleshoot it?
Open the oxygen cylinder.
Open the oxygen cylinder, okay?
Remove the pipe from the wall. From the wall.
Okay, very good. So before we do that, you guys have been talking to your colleagues, or you already knew that?
No?
No.
When you come here, here's the cylinder. What's the pressure in the cylinder?
45.
According to that, or
What's the range of pressure?
From 745 to 200.
No, 745 is this.
no 2200 to
2200 to 40. Yeah. And then it gets regulated down by this pressure regulator to what? Pressure?
45.
To 40.
40.
40. And what is the pressure in the pipeline?
50.
50 plus or minus 5. So it could be 45 to 55. So at least it's 45, here it's 40. So what's going to happen? The gas won't flow because 45 is stronger than 40. So unless you do what she recommended. Okay? Now the oxygen from the cylinder can start flowing. And now you save your patient. Right? So a lot of people miss that last part, removing the pipeline. But now, as you sit here, aren't you thinking, hey, hold on.
Yeah.
There are two features, safety features in an anesthesia machine designed to prevent hypoxic gas delivery. What are those two features?
Oxygen analyzer and the load. For the pressure inside, which is a 40, we can drop to 25 on the oxygen analyzer.
I'm sorry.
The ORC.
Yeah, oxygen ratio controller. Yeah. It's also called a hypoxic guard, right? In this machine, how does it work? So if I had nitrous already on board, and I try to decrease my oxygen,
Go with it.
at some point you will see the nitrous following. You see the nitrous? Not quite. There, the nitrous starts to follow now. You see it?
Yeah.
And conversely, if I try to increase my nitrous, my oxygen follows. And that's done through a chain link. And the chain link assumes that what is in the oxygen pipeline is always oxygen. So here clearly, what is in the pipeline is not oxygen, right? But the chain link doesn't know that. So it's not really a hypoxic guard. It's letting a hypoxic anesthetic mixture be delivered. What's the other thing that guards us against hypoxic delivery? It's called the fail-safe. You've heard of that?
Mm-hmm.
The fail-safe on this machine is this. So basically, the fail-safe says, if there's loss of pressure in the oxygen pipeline, I'm going to shut off nitrous. Because if I don't do that, I will give 100% nitrous. So keep your eyes here, and I'm going to simulate a failure of a loss of pressure. Do you see that? So there's a spring here. If the pressure on the bottom from the oxygen is enough, it will push against the spring and make this hole line up with the nitrous, so nitrous can flow. But if I don't have enough pressure, then the spring will be strong enough to close off the flow of nitrous. Again and again. Now, does the fail-safe work as the name implies? Does it work when the gas in the oxygen pipeline is not oxygen?
No.
So both of those safety features, which are designed to prevent hypoxic gas delivery, fail when the gas in the oxygen pipeline is not oxygen. So these are the 3 points. The hypoxic guard, or the ORC, or the proportioning controller, does not protect against the wrong gas in the oxygen pipeline. The fail-safe doesn't protect or prevent. And if you open your cylinder, you suspect that you open your cylinder, you have to make sure you disconnect the pipeline, right? And so that's very important. And one more thing is, if you had done a pre-use check, you were on some stations where you done the pre-use check, would a pre-use check have prevented this?
If you close the cylinder after you're done,
Only if you
If you plug
What
your
you said,
Your oxygen.
But if it's from past the wall.
you would have to run a check from the pipeline through your O2 sensor to detect?
Hold on. What was your answer?
If it was from your pipeline, if it was hooked, if somebody, like in the mechanics room, hooked past our wall, then we wouldn't be able to tell. If it was plugged into the oxygen.
Okay, first of all, let's go over what do you do in the pre-use check. I think you guys need to bone up on your pre-use check.
Well, wouldn't because the
Well, the
O2 sensor would
pre-use, you have
detect
to-
it if it was like all
You have
nitrous
to
or
open
something.
it,
Yeah.
and then when you do a pre-use and check the pressure in the front, you close the cylinder. So a pre-use check would not.
The problem is not with the cylinder.
So
But the
it
The
would
problem
show
is
in
with the
our O2
pipeline,
analyzer.
right?
Yeah.
Why are we
It
concerned
depends
about
on
it?
what it is that's in there.
Oh, I thought you said.
Is it
if-
No,
air?
I'm
Is it
saying
nitrous?
Right.
this failure mode of the wrong gas being in the oxygen pipeline, would that have been detected if you had done a pre-use check?
I would say,
Yeah,
yeah,
it
because
should
if
have
you
gone.
have
The
the
oxygen sensor would
oxygen,
have went up.
yeah, because it should have gone up.
Right,
to
because
100
in your pre-use
or
check,
over 90.
you take in the pre-use check, you take this, you put it to room air, you check it does 21, you reconnect it, you hit the flush, and you see that it goes to 80. So, but the real answer to this is actually maybe. It's not yes. You're right when you say yes, but you're partially wrong too, because the answer is maybe. It depends. Why?
Depends on what's
Because maybe there
hooked
was
up there.
Because it could be, so the correct answer is it would detect it if the fault existed at the time the pre-use check was made.
Yeah.
What happens if this happens, if the oxygen becomes not oxygen in the pipeline intraoperatively, not during the pre-use check? The other time you would catch it, by the way, is if you were doing your pre-oxygenation. You would never see the entire oxygen go to 60, let alone 60 or even 21, right? So you would catch it at pre-oxygenation too. Not that I'm telling you you should skip the pre-use check. You should do the pre-use check. But you also catch it at pre-oxygenation. But what happens if it happens intraoperatively during maintenance? Like, as I said, the surgeon is 10 minutes into the case, he's done the incision, and then you get this FiO2 alarm. How does that happen?
The expectorant is not going. So.
It would be rare for it to happen in a place like Northwestern. I'll give you a clue. It could happen in a rural hospital.
Oh, like if the oxygen just runs out and there's like, I don't know, very little gas running through.
In a rural hospital, most likely they won't have those. Have you seen a oxygen storage system like at Northwestern? It's a huge cylinder, like 2-story tall, like big, and it's filled with liquid oxygen. So that could last weeks, a week at least. But in a rural hospital, they can't afford that. So what do they use? They use big H cylinders, which are as tall as me. And although it may look like you have a wall outlet in your operating room, but really behind the wall there's a closet with somebody in there. And he's looking at the gauge when the OR is running, and he says the gauge on the H goes to 200. He opens a new H and he closes the old H. What happens is that that new cylinder has been misfilled at the factory. Because even there he can't misconnect it because the threads are different. But in the case that really happened, it happened at the factory. It was misfilled with argon, and the patient died. Because assuming the guy did the right thing, he did the pre-use check, the pre-oxygenation. So inherently he knows this is really oxygen because he's seen everything to tell him that's oxygen. And then suddenly in the middle of the case, it is no longer oxygen. So
Why would they switch it in the middle of? Why would?
because
It
the
runs out.
tank was
Oh,
running
it was
out.
already gone. Okay.
This is behind the wall now, right? So there's a guy who the anesthesiologist or the anesthesia provider is not even seeing. His job is behind the wall, behind the scenes.
Yeah.
He's looking at the gauges. It's getting too low. That's better than the guy running out. So he goes and cuts the new cylinder in, not knowing the new cylinder has been misfilled at the factory. Okay. The groups are blending now. Did I tell you about that case in New Haven, Connecticut already?
No.
Okay. So this is real. So I talked already about the case in Texas. This also happened more recently in New Haven, Connecticut. And there, actually, the sad part was it took 2 deaths for the failure to be detected. The first case, it was a conscious sedation case. It was actually not an anesthesia machine involved. The first victim was an older lady, conscious sedation with nasal cannula, desaturation on nasal cannula because she was getting nitrous, not oxygen. When she was desaturating, guess what they did?
Turn it up.
Turn it up and change the cannula to
Nice.
the mask. Because with the cannula, at least she was still getting some ambient oxygen.
Yeah.
But when they put the mask, that really did her in. So, and then on Monday they had a near miss. Luckily, the surgeon was extremely quick. So the surgeon finished the procedure. The lady desaturated heavily, but she got out of there before something bad happened. And then on Tuesday they killed a younger lady. So it took 2 deaths, unfortunately, to detect it. And unfortunately, what happened there is the pins were removed. So that's why it was pursued as a criminal case rather than a negligence case. Because we have safeguards to prevent those things, but if somebody willingly removes those safeguards. So it does happen, and now the other question is, would this also happen the same way in a piston ventilator? So we're going to go with piston ventilator now. And I'm going to set up the flows. Okay, in the piston ventilator, I don't have the simulation where the gas changes, but you'll have to use your imagination. This is where the fail-safe and the ORC is. So how does the ORC work? You can see how when there's gas flow of oxygen, it pushes on this diaphragm. This diaphragm can float, and you can see also there's a spring that's being compressed. So if there's enough flow of oxygen, the pressure of the oxygen hitting the diaphragm counteracts the spring and creates a flow passage for the nitrous to flow. The nitrous is really being controlled from here. That's how you set this is just a mechanical needle valve. So if I were to decrease my oxygen flow and not even touch my nitrous knob, at some point, because the flow is less, there's less pressure hitting the top of the diaphragm, then the spring will start, you see now it went from 1.0 to 0.9, and now went to 0.6. So that's how the proportioning valve works. But do you also see from this, that if this was really nitrous, that the hypoxic guard doesn't do anything, it would still work, because it's based on the assumption that what is in the pipeline is always oxygen. Similarly, if I were to completely lose the pressure in oxygen by disconnecting this pipeline, you can also see how the spring then, because there's no more pressure on the top, the spring would just push up and shut off the nitrous. So that's the fail-safe. So in the Draeger design, the fail-safe and the proportioning are in the same unit, right? But you can also see how that would also not protect against the gas in the oxygen pipeline actually not being oxygen.
It's all based on pressures.
It's all based on pressures and the assumption that there will always be oxygen in that pipeline. And then lastly, you can also see that if I put this back, that if I open my cylinder, same like in the other design, the gas is still coming out of the pipeline. And that would be the bad gas, right, if this was misfilled. So nothing will happen until I do this. Yeah?
So it'll automatically use the lowest
Yeah,
pressure
if
oxygen
both are on, it's always the pipeline being
supply.
used.
The lower of the two,
Because if you think about it, if both are open, let's say you do your pre-use check in the morning and then you forget to close the cylinder after opening it to check its pressure, then you'd rather it use the pipeline first, so that if something goes wrong, then you still hopefully have the cylinder to fall back on.
But you won't know that it's
It will transition automatically, you're absolutely right.
Yeah.
But still, at least you have a fighting chance, because you still have stuff in that cylinder. But you're right. He's absolutely correct. So if both are open, like right now, both are open. Actually, it's probably a better demonstration on this one. So if both are open, so I'm going to open both. You see? When both are open and then I lose my oxygen, there's no alarm. Okay? But if on the other hand this was closed and I lose my oxygen, now there's an alarm. Okay? Now, we have time, I think, for one more demonstration. Same situation. Okay? We're into the case 15 minutes after incision. Patient is happy and cutting away. And this happens.
Kinked oxygen line or
Okay?
wall.
All right, but you guys are having the benefit of seeing everything in like
Oh,
3D
right.
here.
Okay, sorry.
Let's assume you don't see it, right? Or actually, just you know, what really happened here is this is what we did. This is cute, sort of, you know. So we'll remove that. But I'm going to create a pipeline failure, an honest pipeline failure. So now what are you going to do?
Shut it off and open your
Open the
shut off the
cylinder.
pipeline and open your
Yeah,
cylinder.
you don't even need to shut off the pipeline. The pipeline has failed.
Yeah. Okay, so
Yeah, but yeah, okay, so you can. So open your cylinder. All right, so now the rules have changed now, hasn't it? Your oxygen supply is no longer infinite.
Turn on your ventilator.
So
Well,
so you have a finite supply of oxygen. When will you run out?
Depends on the PSI of the tank
yeah.
and your tidal volume and your flow, your gas flow.
Okay, good. Keep going.
So if you have 2 liters of gas flow and you have 8 liters of tidal volume, then it's 10 liters total, which is depending on the PSI in your tank, it's. We'll tell you how many.
Okay, all right. Let's.
Does that make sense?
No, it doesn't make sense
Oh.
because I think you've talked to some of your colleagues.
So actually, I just read this last night.
Okay, let's first of all, I think an easy way to think of this is like this is your bank account, right? If somebody gave you their bank account, you inherited the bank account. To know when the bank account will get depleted, you know how much you started with, and then if you know you're going to pay your rent from it every month, then you can calculate from there when you won't be able to pay your rent anymore, right? Assuming you have no interest and all that. So this is the same. We need to first begin to know how much is there in the tank. So assuming you go there, you read the gauge, it tells you the gauge reached 1100 psi. How much do you have in the cylinder?
330.
330. So the full tank, which is 2200 psi, is 660 liters. So you have 330. Okay, so now we know we have one part of the equation, 330. Now you look at your oxygen flow meter. Thank you. You look at the setting, and it says 3 liters per minute. In reality, I wouldn't recommend 3 liters per minute because that's wasteful. But this is to make your math easy, right? 330 liters in the tank, 3 liters per minute on the flow meter. When will you run out?
30 minutes.
A little less than 2 hours, 110 minutes, right? Okay. How you round it up, that's fine.
43 divided.
Okay. So you think you have 2 hours. What if I tell you you really don't have 2 hours?
Well, because it's driving the ventilator too, like
Very
it's driving
good.
the ventilator.
Very good. Because if you follow the path here, the gas coming out of the cylinder, some is going to the flow meter, the 3 liters per minute, but there's much more actually going to the bellows. And you are actually controlling that. When you set your frequency at 10 per minute, you're actually saying every minute, 10 times a minute, I want this valve to open and let a bolus of high pressure oxygen go into the ventilator to squeeze the bellows. Just like, so it's as if you have a pneumatic hand squeezing the bellows instead of the bag. And what is the bolus you would give? You would give the bolus equal to your tidal volume. So what is your consumption from the ventilator then?
Four.
Huh?
4 total? Like, because it would push down the liter of tidal volume? Is it we're
Yeah.
1 liter?
But
And
you're
then we're
doing that
giving
how many
3
times a minute?
Oh, well, yeah.
How many times are you doing that?
So then it's actually 10 liters?
Very
We're doing
good.
10,
Yeah, 10 times a liter. So if this was if the tidal volume was 700 ml, what would be the consumption? 7 liters. Very good. And if it was 12 breaths per minute and 700, 8.4 liters, right? So that's the minute ventilation. So what is your total oxygen consumption now? Remember there's 3 here. So it's 1 liter times 10 liters, plus 3, 13. So what's your time to exhaustion? 330 divided by 13, not 330 divided by 3. So you would run out of oxygen much, much, much earlier than you thought. So you don't have 2 hours, you have probably 30 minutes. Okay. Now, you call the tech and you say, bring me another oxygen tank. And he goes, guess what? The whole hospital is down. And guess what? By the luck of the draw, you are the furthest, remotest OR in the Northwestern hospital. So we're going to service all the main ORs first, and then we're going to get to you. But realistically, I'm being honest with you, we won't get to you before your case is over. And you know you're going to run out of oxygen before your case is over. Because now you know you have 30 minutes, not 120 minutes.
Turn off the
Take off the
ventilator.
ventilator.
If you go to an ambu bag, you're not going to be able to give anesthetics anymore, right?
You can turn the ventilator off and just handbag.
Very
And
good.
then go down on your flows.
Very good.
Turn on like air,
So-
if you have air too in the pipeline. Go.
So instead of the ambu, turn off the ventilator, squeeze the bag. So now what is your consumption now? It's 3 liters per minute. So you really do have 110 now. And then nobody really needs 3. You can dial it down to 0.5, right? And now you can even have 660 minutes. Because 330 divided by half is 660, right? Can you still give anesthesia? Yes.
Mm-hmm.
Can you still use a vaporizer?
Mm-hmm.
Yes. Can you still give PEEP? Yes. Now your hand will be a bit tired, but your patient will be safe, right? So these are some of the teaching points we wanted to get across today.